William S. Burroughs once said, "The purpose of technology is not to confuse the brain, but to serve the body." So how about we do just that? Welcome everyone to this here first episode of Amelia's Weekly Fish Fry of 2021. We made it. This week we are talking about brain-hand communication and how a new wireless device could help people with severe upper limb injuries live better lives. But before we bring in Dr. Scott Frey, how about a little news you may have missed? Code is different than just about everything edition. So, code is not a language, and it's not math either. At least, not to the brain, that is. Do you think you have to be good at math in order to be a good programmer? Or do you think that language skills are more important than math in the world of programming? Well, a new study was just released from MIT that centered around this very thing, the relationship between language and other cognitive functions. And this study says coding is a brain beast all to its own. So in this study, this team at MIT found that reading code does not activate the same regions of the brain that involve language processing. No, instead, it activates a very special area called the multiple demand network that is in charge of processing really complex cognitive tests like mathematics or crossword puzzles. Okay, our answer is loud and clear, right? Coding overlaps with math. Sure, makes sense. Well, not so fast, because that's not quite the answer either. Reading code actually relies more on different parts of that network than math or logic problems do. So coding does not precisely replicate the cognitive demands of math or crossword puzzles either. So, how did they come up with these findings? So first, their test subjects were a bunch of kid programmers, which is absolutely adorable, who were proficient in Python and Scratch Junior. Each programmer was put in a functional magnetic resonance, or fMRI, scanner and shown snippets of code. Then they were asked to predict what action that code would produce. What they found was pretty cool. Not only did these coding tasks mainly activate the multiple demand network, which is typically recruited for tasks that require holding many pieces of information in mind at once, but also that reading code actually activates both hemispheres within that multiple demand network. And not only that, Scratch Junior was even more in the right side of the brain than the left. So this is important because previously published research contended that math and logic problems tend to concentrate in the multiple demand regions in the left hemisphere, and stuff that involved spatial navigation relied more on the regions in the right hemisphere. So this research has also been supported by a similar research study coming out of Johns Hopkins University that also found that coding activates that multiple demand network rather than the language areas of the brain. The lead author of the MIT study, Anna Ivanova, says, "Understanding computer code seems to be its own thing. It's not the same as language. And it's not the same as math and logic." Yes, indeed, a beast of its own. So, if you want to check out even more information about this research study at MIT, I've included a couple links below the player on this week's Fish Fryin' page on eejournal.com. So when I was first hired here at Tech Focus Media way back in 2005, publishers of EE Journal, one of my coworkers, Kayla, was really interested in bionic limbs. I remember having a number of early conversations with her way back then about the future of bionic limbs. She was really passionate about helping wounded veterans come home from war and how we in high tech could accelerate their paths to recovery. So when I got this email about Dr. Frey's research, I jumped at the chance. in honor of Kayla, my lychee martini partner in crime from way back when. So it's time to bring in Dr. Scott Frey and talk about how he and his team are helping to personalize recovery from lost limbs, one wearable device at a time. Welcome, Dr. Frey. Thank you so much for joining me.
Yeah, what a pleasure. Thank you, Amelia, for inviting me.
Okay, so we're talking about advancements in brain-hand behaviors today, and you are developing a way to help people with severe upper limb injuries function in everyday life without amputation. But before we get into the details of your new technique, Dr. Frey, can you set the stage for us? How did you get interested in this subject?
Yeah, I think it's an interesting merger of one's personal life with their professional life. So I grew up with a mom who was suffering from multiple sclerosis, disease of the central nervous system, the brain, and the spinal cord. And one of the things that she struggled most with as that disease progressed was the use of her hands. So I remember as a child being very aware of just how important it is to have good hand function in order to live independently and to do all those things that when we're healthy, we really take for granted, dressing and caring for the house and taking care of business and whatever we do. Most of those activities to some degree involve our hands. And so I was in essence my mom's hands from the time I was really little. And I think that planted the seed with me that as I gravitated into studying the brain and behavior, there was a lot that we could learn about how the brain controls the hands that might do some good in this world.
Absolutely. Now, Dr. Frey, can you explain a bit more what particular challenges you're looking to solve here?
Well, for the past 15 or so years, I've been very interested in people who have experienced an amputation of a hand, sort of the most dramatic kind of injury that we can imagine occurring to our upper limbs. And I've been interested not only in interventions for those individuals, but also in what we can learn about them from a basic science standpoint. So my particular focus is in neuroscience. I'm a neuroscientist, and I've been studying how the areas of the brain that are involved in controlling the movements of the hands or experiencing senses through our hands, things like temperature and touch and vibration and all those amazing senses that we can perceive with our hands, how those are processed in the brain. And one of the interesting questions that I've been approaching by looking at people with amputations of a hand is what happens to those areas when that amputation occurs? Do they just sort of freeze in place? Do new functions take over that vacated real estate? And so forth. And then on the flip side of that, what can we take from what we're learning about the basic science of how the brain responds to loss of sensory input from the hands and a diminishment of motor signals leaving the brain to the hands to try and develop more effective interventions for people who've experienced amputations or major limb trauma.
Very interesting. Now, Dr. Frey, can you tell my audience a bit about your technique? What all does it involve?
Yes, so this is kind of a new adventure for me. This is an area that has really grown out of my interest in connecting the brain science with real world behavior. So one of the limitations that we have in studying the behavior of people like the individuals I've been talking about who have an amputation or even a neurological disease that maybe affects hand function is how to objectively quantify those changes in their functionality, whether it's using a prosthesis, whether it's using transplanted hand, whether it's using a hand that is recovering from injury. How do we quantify that behavior? And the traditional ways of doing that have been to give them standardized tests of performance, either clinically, perhaps at the bedside, like an MD might do, or in a laboratory like mine, where we might hook you up to all these fancy motion monitoring devices that give us a lot of information about the speed and precision of your movements. But the trouble with that approach is the trouble with a lot of the ways that we approach studying behavior. We don't really get direct insights into what people are doing when they leave the laboratory or the clinic and go home in the real world. So somebody can show you their best levels of optimal performance on lab tests that we perform, but that doesn't mean they're going to perform at that level when they go home and they're working around their house or they're engaging in whatever recreational and occupational activities they partake in. What we'd really like to know is how you do out there in the natural environment. And so the technique that we've started using involves some fairly common technology now. It's essentially making use of wireless accelerometers that are placed at different locations on the upper limbs. We happen to use some commercial actigraphs that are worn on the wrists like wristwatches. Not all that dissimilar from the Fitbits that you see people walking around with to monitor their steps and other activities. But we've developed some techniques for taking data from those wrist-worn sensors and using it to make really good objective measurements of how the two limbs are moving, whether they're working together, whether they're working independently of one another in real time. And we've been fitting those devices not only to, let's say, in the case of an amputee, not only to their healthy wrist, but also to the wrist, if you will, of their prosthetic device. And you can imagine a similar thing in this new grant that we've just received, where we'll be looking at people with major limb trauma, but who haven't had an amputation. We'll be studying the movements of their good arm and their injured arm and looking at how those work together in real life.
Wow, this is really cool, Dr. Frey. Now, you're part of a team of other scientists working on this project, right? How do you and your team see this kind of technology playing a role in the future of recovery in this field?
Yeah, so I am part of a team, and I realized very early on that the science that I'm interested in doing is not something that can be undertaken in a silo, that we really do need to connect across other disciplines. And so in my own lab, I have a wonderful team of people that work with me from different backgrounds, motor neuroscience, engineering, and so forth. But in much of my research work, I also partner with clinicians, people who are seeing patients who have catastrophic injuries to the hands, and surgeons who are actually engaged in trying to do the kinds of repairs to the bones, the nerves, the tendons, the muscles, the vessels, and so forth, to try and promote the best outcome for those individuals. And what I found is that when we start talking about using our technology to provide those clinicians with information, quantitative and objective data on how their patients are performing out there in the world, they get really excited, because normally they're only able to really study their patients from the perspective of when they come into the clinic, giving them a test of how their motor function is returning or their sensory function. But again, this doesn't necessarily mean that these individuals will be performing the same way out there in the real world, where things really matter, where the rubber hits the road, right? So if I'm a patient recovering from, let's say, dramatically an amputation, and you fit me with a prosthesis, yeah, maybe I can come into the laboratory and accomplish some tasks with the prosthesis and show you how well I've learned to use that device. But what I really care about, and what the clinicians really care about, is how you're doing when you go home. And so this kind of technology will give us that information that we haven't had access to before. We can record data with these wireless sensors across numerous days and really boil that down to a unique personalized profile of how a person is using their limbs or prostheses out there in the real world. And then ideally, we'll be able to work with the clinicians to develop more effective interventions and evaluate the effectiveness of those interventions in these individuals.
That makes sense. All right, Dr. Frey, it is time for your off-the-cuff question. Now, I'm going to throw a little Food question your way. Here is the COVID special. Now, if you could have one meal anywhere in the world right now, whether you need a passport to get it or the restaurant's been closed due to COVID restrictions, what would you have?
Oh, this is such a great question. I love it. And I have an answer for you immediately. I would go to northern Italy, to the Dolomites region, and I would have one of those wonderful thin crust pizzas like you can only get in Italy. And I would wash that down with a couple pints of the best local beer that I could get. And that would make me a very happy man indeed.
I love it. And that sounds absolutely delicious right about now. Well, Dr. Frey, I think that's all I have time for today. Thank you so much for joining me.
Thank you so much, Amelia. I really appreciate it.
Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EEJournal. If you're into Twitter, you can monitor our tweets at EEJournalTFM. And don't forget, if you want to follow my personal Twitter account, check out Amelia D 1978. And hey, if LinkedIn is more your thing, sure, I dig it. You can follow us or me on LinkedIn as well. And we have a YouTube channel, youtube.com/EEJournal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series hosted by yours truly. And you can subscribe to our EE Journal YouTube channel as well. Also, by clicking the links below the player on this week's Fish Frying page, you can subscribe to this here podcast through Spotify, Podbean, the iTunes Store, or just about anywhere you get your podcasts. And remember, if you want any further information about the stories covered in today's show, just head on over to eejournal.com and look for this week's Fish Frying page. Thank you everyone for tuning in. If you know of any cool new technology or heck, you just want to chat, I promise I will respond. Shoot me a line at amelia@eejournal.com or post a comment on our forums on EE Journal. For the week of January 8th, 2021, I'm Amelia Dalton, and you've been fried.